Okay, so I'm going to be creating this video for a student who's asked me a question with regards to how to export contours, or to source contours and then export them to CAD to use in a CAD package. And that's pretty much what I'm going to go through here. Now there's a couple steps that I'll be covering. Ultimately it's quite a simple process to export to CAD, but since I'm going to be sourcing the elevation data, there's a few other steps that I want to go through first. So let's crack on with that video, and yeah, hopefully you find it fairly useful. Cheers. Okay, so we're going to start by creating some project folders, and I'll create it in the usual desktop place. So my project is called Isolweenie, and then I'll just create a few extra folders inside that project folder for my QGIS projects, as well as the data. And then inside the data folder I'll have spatial, and I think I'm going to leave it there. Possibly inside spatial I'll create a new one called Raster. I can see that I might need a Raster folder as well. Okay, so we can open up a new session of QGIS, and we just want to locate the position of our project, so our study area. So I'm going to turn on a layer from the Quickmapservices, and this Quickmapservices is a plugin that you can turn on via your manage and install plugins. So if you go and search for Quickmapservices, I'll show you where it is. Quickmapservices. So you just go type Quickmapservices in your search bar here, and you go and look for this one, Quickmapservices. Turn it on or install it, and then it'll give you a new option under the web menu with a Quickmapservices option. And you'll see I've got quite a few options here. I think by default there's not that many. So what you can do to access all these extra ones is just go to settings and then select more services, and then just click on get contribution pack and install that, and what that'll do is then give you access to all these other services. So the layer I'm going to turn on to locate my study area is Open Topo Map. So let's turn that one on and then zoom into our study area, which is in Swaziland, and it's up here just below Mbane, and it's Isolweenie. Okay, so this local municipality, or this study area, is called Isolweenie. Right, so what I want to do is I want to create a grid that will be used later when we export the DXF, that can be used to reference the contours in that DXF package. So I'm going to start off by creating that grid. And before I do that, I'll just need to make sure that I have got the right projection selected for this particular project. And so I'll just go down to EPSG down here, and my projection is the ESRI Authority ID 102568. Okay, so I'm going to select that one. So it's Hartebest took 94 LO31. So let's say apply and OK, and then you'll see the ID has changed and my coordinates are now in meters. I think they probably were in meters because the previous coordinate system was pseudo Mercator, but anyway, this is where we are. So what I'm going to do is create a grid, and I want to start off, let's just zoom out a little bit and see, actually no, I want to zoom in down here. Okay, so this is my study area down here, and I'm going to start off using these meters as my coordinates, which I will then create in an Excel spreadsheet. So it's going to start off with about 1.5, okay, and then I'm going to increase it in thousands. So I'm going to go 1,500, 1.6, 1.718, about 18. So my last point will be here somewhere. And then also let's start off on that latitude. There is minus, what is that? Is that 29? Is that 29 million? How many noughts are there? 2.9 million. Yeah, 2.9 million. So we're also going to go up in thousands there. So it's going to be 292. 000, and then 292.1000, and so we'll create that grid. So let's go and quickly do that in an Excel spreadsheet. So let's go into our project folder, spatial. We'll create a new folder here, we'll just call it tables. And then I'll just go inside there. I'm going to right click and create a new spreadsheet, Microsoft spreadsheet. I'll just call it coords for coordinates. Let's open up that one. Okay, so we're going to go point X, Y. So point A, first point, now this was the first point, it was 15,000. And then that first one was minus 292, and then 4 noughts, 1, 2, 3, 4. Okay, so now that is the first point, and we need to repeat that for the remaining points. So then this one's going to be minus 292, and that was 1,000. And then this one's going to stay 15,000. So we're running down the latitudinal points now. So that is going to be B, C, D. These will all be 15. And then the next one's going to be 16. And then these, we can just increment those in thousands. So that is perfect. So now we can copy this. And we'll do that another 3 times. Then we got 16, so 16. Then it was 17. Repeat that. And the last one, 18. ABC. All right. To P. Alright, so let's save this, and now we just need to make sure we save it as an Excel spreadsheet, I beg your pardon, as a comma delimited text file, so it's a CSV. So we're going to save as, browse, we'll save it in the same place, but now just make sure we choose the right CSV. So you see there's a couple options there. We want to choose comma delimited, and we can say save, yes. And now let's close this down. No, I've already saved it. Okay, so back in QGIS, now we want to bring in those points. So we're going to add the CSV. So we go to our Open Data Source Manager, select our delimited text layer. I'll go find that new CSV that we've just created, which was in tables. It is not that one. It is Weenie tables. There we go, chords. Open. Okay, that brings it in. That looks good. Okay, just make sure that you can see your table here, and there are separate columns for the 3 different fields. And then make sure that you got the right coordinate reference system. So this needs to be the same as the coordinate reference system you chose when you first set out your project. Okay, so that should be good. So now we can say add and close. And let's see, did those all come through? There they are. Okay, let's just zoom out slightly, so let's make this 15. Maybe a bit more, let's maybe put it 25. Oh, not that much, 20 would be good. Okay, so what I maybe could do is change the color of that just so we can see it a bit better. So choose something a little easier to see. I don't know, maybe size would be better if I change that size up to 3. That's pretty big, but that should work. Okay, so there we've got our, so now we've got our points. So now this is going to be the grid that we use to reference the DXF at the end of the day. So the next thing I want to do is I want to create a sort of a study area polygon, which is the full extent of this grid. And then I also want to put in the longitude and latitudinal lines. And the last thing I will then do is once I have that, I'll go and extract the DEM and then create the contours from a SRTM that I'm going to download. So let's create the other layers, and I'm going to create, in this example, I want to create a Geopackage. So let's create that Geopackage. Okay, so let's do that in browser. So I'm going to add a new directory to my favorites in the browser, and it is Ezelweenie. There it is there. I'll just rename this so it is a little easier to read. Oops, supposed to delete that. There we go. So now I've got our Ezelweenie folder. Now that's just a directory pointing us to the folder that we created on that desktop. So this is where all our data will be. And I'm going to create a new Geopackage in the spatial folder. So I'm just going to right click on spatial folder, and then I'm going to go to new and choose Geopackage. And this Geopackage is going to be called Ezelweenie. Whoa. Okay, let me turn off my caps lock. And the new table, so the first table will be grid lines. Grid lines, and it is a line. And we can give it a column and just call it 20, and then just make sure that it's got the same projection as the project, and then say OK. Okay, so what we've now done is we've created this Geopackage, and so we can create new layers in that Geopackage and also save existing vector layers to that package. So I'm going to go in and get my coordinates, and I'm going to export them to that Geopackage. So now I want to go and select Geopackage, choose the file name, Ezelweenie. Okay, there it is. Then the layer name is, these are my coordinates. Okay, there's my coordinates. And it's got the same projection as the project, etc. And so we can say OK. Now if we go back to our browser and then refresh this window, we should now have two layers in the Geopackage. If I just right click and have a look at the layer properties, we can see what it looks like. And that is it. And it's got, oops, oh, why is it not seeing that? Maybe I need to wait longer. Let's just try that again. So I'm going to go layer properties, preview, attributes. Okay, so it's got the columns that are created in that Excel spreadsheet, except this is no longer linking to the CSV. This is linking to the coordinates layer or the codes layer in my Geopackage. Okay, so what we can maybe just quickly do is we can delete this one and then just recolor that one. So what I'll do is I'll just go to styles. I'm going to copy the symbology and just dump it onto the new layer, and then we can delete this one. Okay, good. Next step, I want to create those latitudinal lines, and then also to create a polygon that goes around the outskirts. So let's create a polygon layer. So let's create a new Geopackage layer. We'll go and select the database, and it's Ezelweenie. And this one we're going to call study area. Study area, it's a polygon, and we will give it a new field, just one new field, and also make sure that we've got the right projection, and then say OK. And then add so now this is asking us, do we want to overwrite and create a whole new Geopackage? And if we selected overwrite, it would have a bit of conflicting issues here. So we just want to make sure we're adding a new layer to an existing Geopackage. So select add new layer, and there we go. So there's our new layer. I'm just going to quickly style this and do it something like that. Let's maybe make this outline black, and then possibly make it transparent. So we're going to make it 50% opacity, so we can see through it. Now yellow is not a great color because yellow is the same as a selection color, but it's not important at this stage. So let's leave it as yellow. Okay, but there's nothing there obviously because we haven't captured anything. So then we're going to start editing. Okay, and then I'm just going to set some snapping options so that we can snap to our existing grid. So I'm going to say advanced configuration. Oh, hello. Okay, yes, there we go. I was clicking the wrong button there. So I want to click on the little eyeball that it allows me to edit the advanced configuration, and then set the Ezelweenie coordinates as the layer to snap to. Okay, there we go, we can close that down. So now we can add a new feature. So we'll just add a full extent, and this is going to be called our study area. Then right click to finish, and we'll just give it that same name. Okay, now there we go. We'll just drag it underneath and just save it. And we can do the same thing for some longitudinal and latitudinal lines. So we'll do that same thing again. So we're going to create a new layer. It is going to be saved inside the Geopackage. It is going to be, okay, we're going to name it, what are we going to call this? Let's just call this lines, or grid lines. Grid lines, it is lines, or line, same coordinate reference system as the project. We'll also give it a name. I might not actually name anything in here, but just having this field might be useful at a later stage. We'll say OK. And once again, adding to a new layer, we're not overwriting an existing one. A table, oh, okay, so I've already got those lines. Did I create those already? Yes, I did. When I first created the Geopackage. Okay, so that was silly. So I'm just going to say no and cancel, and then just go and add that layer from the Geopackage. So that's probably a good thing. So I can show you that you can overwrite layers that are already inside your Geopackage, but what we did is when we first initially created the Geopackage in the browser, it gave us the option to create a new layer called grid lines, and that's what we did, or any layer really inside the Geopackage. So now we're going to add this to our project. So you can select it and should be able to drag it across, but I'm going to use the data source manager, go to Geopackage, and I'm going to create a new connection. So I go new, I go and find the Geopackage that we're using. We use that one, and then connect to it, and that is not right, so I want to remove that. Yes, remove, yes. I want a new connection, right? I want to connect to this Geopackage. Open, and then connect. There we go. So it was connecting to one that I created previously, but we want to make sure we connect to the right one. So just make sure that your path name is the correct one and you're pointing to the right Geopackage. And grid lines is the layer we want to add, so you can select that and click add and then close. Obviously nothing's shown yet because it's a brand new layer. We haven't actually captured anything, so we'll just start capturing this layer. But before I do that, I'm just going to change this color to black. There we go. Okay, and we don't actually need to have our OpenTopo map open in the background. It's just kind of confusing us a little bit. So now we're going to create those new lines. We can also actually turn off our study area map, and let's create those new lines. So we're going to toggle editing. Now we've already set the snap settings, so we just need to create new lines. Okay, so that is our first line. Right click to finish. Name, we're not going to worry with names. And every time you get close enough to a point, you'll see the little pink box will pop up to indicate that you have snapped to that closest point. And then we'll do the longitudinal lines as well. This was 15. This was 16,000 meters, etc. Right, so we can save that. There we go. Okay, so now what we have is a little project with a grid and a study area that we're going to use to clip our 30-meter SRTM from the data that we are going to download next. So that is the next step. But before I do that, I just want to save this project. So I'm going to click on save, go and find my project folder, and we'll just call this we'll also call it Islwini. There we go. Okay, so now we're happy with that. That's been saved. Now we're going to go download the SRTM. Right, so let's go online and download that SRTM. So first thing I want to do is just have a look at what we've got here. This is a little text file that I've got just to remind me where what the link is to the 30-meter SRTM. And this is what it is. So the SRTM stands for the Shuttle Radar Topography Mission. And this is a little description downloaded from Wikipedia. And that's a link to Wikipedia. And then this is the link to the actual server where you're going to download your 30-meter grids from. And then this is a little a sort of a third link where you actually need to register before you can download. So if you went straight to this link, it's going to say, what is your login? And if you don't have it, you won't be able to download. So just make sure you go and log in before and create a little account before you actually start downloading. So I'm going to copy this, open up Google Chrome or any browser. I'll just paste this in there. That should take me straight to the server. Right, so now we wanting to download the block corresponding to Swaziland. So we can just scroll in here and you'll see there's the whole, the sort of the interior of Swaziland is covered by one block. So that's going to cover our study area. So if we wanted to do or to download all the SRTMs for the whole of Swaziland, we'd need to go get that one, this one. So we'd probably need to download, by the looks of it, 1, 2, 3, 4, 5, 6 would cover Swaziland at the end of the day. But we just are concerned with this area, so we're going to click on this one to download it. Right, so yes, we want to download that digital elevation model. It shouldn't take too long. It's going quite quickly. Right, so what I'm going to do next is go and grab that SRTM, and it's not that download folder, it's a different one. It's this one here. There it is there. So I'm going to cut that and go and paste it in my project folder under the Raster folder. And then I'm going to just extract it. And extract, and then whoops, there we go. So now we've got this HGT file, which is a raster file, and I'm going to put it in the parent folder. Okay, so all I did is I cut it out of that folder, and then I'm just deleting the zip folder, and then also that folder that it extracted to. Right, so there we go. That is our DEM, which we can now add to QGIS. So let's go back to QGIS. And we can turn off shut down our browser. Back in QGIS, I want to add a new layer, and it's a raster layer, and it is in the raster folder, and there it is there. Add and close. Okay, there we go. So now if we zoom to the full extent of this and turn on our topographical map again, you'll see it is the 30-meter DEM for the whole, well, most of Swaziland in this instance, but we're just interested in this area here. So we are going to use the study area shape to cut out the DEM for that particular area, and that's what we'll use to then create the contours. So let's do that. So we'll go to raster, extract, and we're going to clip raster by a mask layer. So the input layer is the HGT, so that's the new SRTM, and study area is the only polygon, so it's automatically choosing the mask layer for us because there's only one polygon layer. We're going to use the source CRS, which I think is WGS84. Let's see here. That one, and then the target when we want it to be is actually no, I think it's this one. I think we just go source will be how to best hook. So let's just see if this works, and then so what I'll do is I'm not going to create a permanent raster. I'll just run this to see if that works. Okay, what is my problem here? Oh, I left out something. So what did I leave out? I left something out. Let's just try that. Did that say optional? It is optional. Input layer, study area. Maybe it is because I got the wrong CRS. Let's just try this and see if that works. Okay, so that was the issue. I needed to set the actual CRS from the original raster and then the new one. So now let's just double check that that is the case. This is the output. This is the new raster. There's the old one. So if I go to output properties, the information here should give me this CRS, which is hard to best hook LO31 east north up. Perfect. Okay, so that's a temporary layer. Let's just create a permanent layer by exporting it. So I'm going to say save as. GeoTIFF is fine. I'm going to go and put it in the raster folder. There we go. I'll just call it DEM. Save. All this other stuff is all perfect. Is there anything else I need to add here? That's fine. Let's say OK. So it adds it to the map, so I can remove that. I can also remove the original. I like to remove layers if I know I'm not going to use layers again. I try and remove them as often as possible, so that my layers panel doesn't get too cluttered. So now what that SRTM is it's an elevation file. These are each cell is an elevation value, and they're 30 by 30 meters. So if we have a look at the cells, you can sort of see them here. So there should be 30 meters. There we go, 30 meters by 30 meters. And then each one of these will be an elevation. So the bands are elevation above sea level in meters. Okay, there we go. Right, so that was easy enough. Now what we can do is create the contours. So we go to raster again, and we're going to extract the contours. So from the DEM, the interval of, let's just say 5 meters, it's going to create a new vector layer with an elevation column, and the elevation column title is elev. So you could call this alt or contour, whatever you like. I'm just going to leave the default there. I'm happy with that. And there we go. It's going to create a temporary one. Let's just see actually if we can save to file and choose Geopackage, and then go and select that Geopackage. No. Okay, so I'm not going to do that. That wants to create a brand new one, so I would rather import it. So I'm going to create a temporary layer to start. There we go, those contours look good. And then I'm going to export this to Geopackage, which is that one. Okay, the layer name is going to be contours. There we go. Anything else? No, happy with that. Let's say OK. And then remove the temporary layer. And let's just have a quick look at the attribute table. So we go back to our Izzleweenie. In browser, you can go back to Izzleweenie. And you could have also done this through the Windows panel, the layers panel, and then just open up the layer properties. Oh, it's good. It's got the same projection. And then the attribute table has got that new column that I was talking about. So there we go. There's the field, or the new column, with the elevation value for each of those features. Okay, great. So now that's something you can export as a DXF and then load in a CAD package. So that's actually quite simple. And we're going to use the option, we're going to export a bunch of layers. So what I'm going to do is I'm just going to remove everything that I'm not using anymore. Okay, save my project once again. And now we can export all of those to a DXF. So under project, select import export. So export project to DXF. So that's going to export everything that's in our project. and I'm going to save as. So it's a, let's just call it a vector layer, and what should we call it? These, I mean, it's the DXF, so let's just go contours let's go contours CAD, and then it'll use the extension DXF. Okay, save. Right, this is all good. Okay, now there's a couple options down here. You can first of all choose no symbology as your default option, and it's not going to export any labels. Now I've tried this before. I wanted to pull through text from the grids that I could then use for georeferencing and scaling in a CAD package, but I haven't been able to pull those through. I'm not sure if there's a bug in the system as of the 18th of May 2020. What is this? Corona 3.10 version, I actually don't know. But anyway, at this point in time I wasn't able to pull through the labels. Now it could be something I'm doing wrong, so just fiddle with that and see if you can figure it out. So the other thing I want to do, export features intersecting, okay, so we're just going to export features intersecting the current map extent. So if there was anything sitting outside of our extent, that wouldn't come through, but it's not important because we are at the full extent of all of our features in these layers. Right, that's it. So now we click OK, and that was quick. Export completed. Okay, now it's completed. So what we should have now is a DXF in our project folder, which is here somewhere. There we go. So under spatial, we should now have a DXF contours CAD. So now, and it's 902 kilobytes. So you should then be able to go into your CAD package, whatever that is, and then add that layer. And since you know what the coordinates are from that Excel spreadsheet, you should be able to import points if necessary. And if you do need to scale the vector data, you can use that grid that's been exported with these contours, as well as or just the Excel spreadsheet data that we sent through earlier. So now I'm not going to show you that part of how to import data into a CAD package, but that, if you are working in CAD, should be easy enough, especially if you're proficient at CAD. What we can do as a last step, just to show you that it did work, is just add it to a new QGIS project. So if I go and add a DXF, there we go, to a new project, click add, we'll select all of those, okay, and close. There we go. That's what it looks like. Now the CAD hasn't got a coordinate reference system assigned to it. So this is, because these are CAD entities, you might need to come in here if you were going to use this in QGIS and then just assign the correct coordinate reference system. Something like that. And then you would do that for the others. But not, I don't think that's going to be an issue if you're going to be using CAD. Okay, and that's how you do it. It's fairly straightforward. Whoa, that's disappeared. There we go. So that's pretty straightforward. And if I just make sure that that's working properly, I can turn on Google Imagery. There we go. My data's there somewhere. Just change these contour colors to something that will stand out on top of a satellite image. And then just double check the attributes that have come through. Now, here we go. We've got our layer, so we can turn off the grid lines if necessary. So, for instance, in that example, so now this is if we were still working in QGIS, obviously, you can then go ahead and then turn your layers on and off. So, for instance, if you were bringing a layer in from a DXF, this is what you would do if you just wanted to show a certain layer and not others. And that's it. Pretty straightforward. I hope that's been useful. Give me a shout if you have any questions. Cheers.